Welcome to Organic Chemistry, Lesson 6. Now we're going to talk about alcohols. Alcohols, where one hydrogen atom has been replaced by a hydroxy group, meaning an OH group. The general formula, CnH2n plus 1 OH. An example is ethanol. Ethanol has 2 carbons, therefore eth, un because there's only single bonds, and ol because there is an OH substituent. Here is the structural formula for ethanol. Here is the condensed structural formula, therefore CH3, a CH2 and an OH. And then your molecular formula is just the amount of carbon atoms, 2, amount of hydrogen atoms, 6, and a oxygen. Now, very important, for alcohols you need to know how to classify carbon atoms. There's 3 types of carbon atoms. The first one is primary. A carbon atom that is bonded to one other carbon atom is called primary. Let's look in this molecule. Here is a carbon that is bonded to only one other carbon. Therefore, this carbon is primary. This carbon is also bonded to just one other carbon. Therefore, primary. And then this carbon is also bonded to only one other carbon. Therefore, it is primary. The next type of carbon atom is secondary. That's a carbon atom which is bonded to 2 other carbon atoms. So if we look at this carbon here, you can see that it is bonded to 2 other carbon atoms. Then the third type of carbon atom is tertiary. A tertiary carbon atom is bonded to 3 other carbon atoms. So let's look at this carbon. It is bonded to 1, 2, 3 other carbon atoms. So primary carbon atoms bonded to 1 other carbon atom. Secondary carbon atoms are bonded to 2 other carbon atoms. And a tertiary carbon atom is bonded to 1, 2, 3 other carbon atoms. Now, classifying alcohols. A primary alcohol is where the carbon atom bonded to the OH group is also bonded to one other carbon atom. Or a secondary alcohol is where the carbon atom bonded to the OH group is bonded to 2 other carbon atoms. And then for a tertiary alcohol, the carbon atom bonded to the OH group is bonded to 3 other carbon atoms. Let's look at an example. So, a primary alcohol, the carbon bonded to the OH group is bonded to only one other carbon. Therefore, this carbon is primary and this is then a primary alcohol. Secondary alcohols. The carbon bonded to the OH group is bonded to 2 other carbons. Therefore, this is a secondary alcohol. Tertiary alcohol. The carbon bonded to the OH group is bonded to 1, 2, 3 other carbons. Therefore, this is a tertiary alcohol. Uses of alcohols. Methylated spirits, which is ethanol and methanol. Alcoholic beverages, which contain ethanol. Industrial solvent, ethanol is mostly used. And then ethanol is also an antiseptic. It's very important to note that all alcohols are poisonous. Methanol can be absorbed through the skin and is very, very dangerous and therefore not used that often. IUPAC names of alcohols. For alcohols, the suffix, meaning the part at the end of the name, is "-ol". So always now at the end of the name you'll have the "-ol" part. The prefix or the base name is prop for 3 carbons, and then you can also have alkyl groups as usual. Example 1. Give the IUPAC name of this molecule. The first step is always to identify the functional group. If you see an OH group, you know this is an alcohol. The next step, find the longest carbon chain. So, if you count your carbons, 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, you'll see that 5 is the longest chain that you can identify. Number your carbon atoms. You can either number from the top, the green set of numbers, carbon 1, 2, 3, 4, 5, or you can number from the bottom, the purple set of numbers, 1, 2, 3, 4, 5. Do not number from this side, then you'll only find 4 carbons, 1, 2, 3, 4. Remember, there are 5 carbons in your longest carbon chain. Now to decide which is the correct set of numbers, the blue-green ones or the purple ones. The OH group is your functional group, and therefore it should be at the lowest possible carbon number. The green set and the purple set gives you carbon 3 for the OH group. Therefore, you cannot decide it by that. So now you look at it another way. It doesn't matter if you number the purple numbers or the green numbers, the substituent, the methyl substituent will always be at carbon 3. So in this case, your numbers are both correct. Now, very important. To name this alcohol, you tell me where the substituent is, which is carbon 3, 3-methyl, pent, because you have 5 carbons in your longest carbon chain, and then 3-ol, because the OH group is at carbon 3. Example 2. Draw the structural and condensed structural formula for 2-methyl propan 1-ol. So the first step is to draw your 3 carbons because it's prop, which means 3. Now you insert your substituents. 2-methyl, so at carbon 2 there's a methyl group, and 1-ol. So your alcohol OH group is at carbon 1. Then the condensed structural formula, you have an OH, CH2, CH, and then a methyl substituent, and then your CH3 group. Example 3. Give the IUPAC name of this molecule. Now this is not the structural formula, so this first step is always to draw your structural formula from this molecule. So CH3, CH2, C, OH, C, and another CH3. So CH3 is there, CH2 is there, you need an OH at this carbon. The next carbon has got 3 CH3 groups. Very important to be able to go from there to your structural formula. Now for the name. The first step is to identify your functional group. You see an OH group, so therefore you know this is an alcohol. Then you find your longest carbon chain. No matter which way you count, you get to 5 carbons. And then you number them. 1, 2, 3, 4, 5, and from the other side, 1, 2, 3, 4, 5. Now the OH group is always at carbon 3 in this case. Therefore, your substituents need to decide if it is at carbon, better at purple numbers at carbon 2, or better for the green numbers at carbon 4. You have to choose the purple numbers, because then the methyl substituents are at carbon 2. So 2,2-dimethyl pent 3-ol. 2,2-dimethyl because there's 2 methyls at carbon 2, pent for 5 carbons, and then your ol OH group at carbon 3.